Hello everybody, getting ready to do lesson 2.3 of Algebra 2 Math Part 2. Today we have a 40-point class worksheet today for adding, subtracting, and multiplying polynomials. And we have 2 points here of note-taking. Here's our standard up here. And get into our lesson. So, example 4, multiplying 3 binomials. We have these 3 here in a horizontal format. So this is what you would do. You would line these things up like this. We're going to keep this outside. We're going to multiply these 2 binomials together, and we get that trinomial there. And then we're going to multiply now by grouping. We're going to multiply each member of this binomial times the trinomial. And we get this big long expression here that we need to combine like terms together. X cubed. Do we have another cube? We don't. But we have a couple for x. We got x squared here. Combine those. And then we got negative 5x and negative 12x. We combine those, and we have a constant out here. So that'd be the way that you would multiply those. So find a product here. We have a cube of this. Students, this is yours here. And this your independent practice. Let's do practice now. So find the product. Yeah, that's what we have here. So what will we do next? So we use patterns here with a difference of a cube. We have a pattern here that we can multiply this out, a minus b cubed. This is the pattern here, and then we're going to use that. Here's another example of a difference of a cube pattern, what we would do in this situation here, p minus 3 cubed. This will be how you would plug in your numbers into that. So for up here, we have xy minus 4 cubed. So we have a cubed, which is xy, minus 3 times a squared 4, which is what? And minus 3a squared b, so minus 3a squared b. Following this pattern here, this is the pattern that we want to follow here. This is an example of the pattern, and now we're going to transfer this into this pattern. So we get xy cubed minus 3 times xy squared 4 plus 3 times xy 4 squared. We move our square over here and we add this, and then minus b cubed is what this would be, minus b cubed. So you have to follow this pattern here and then plug these terms into this pattern, and you come up with this big gnarly expression here. And then when we combine like terms, or we get through applying our powers, we get x cubed y cubed minus 12 x squared y squared 3 times 4, and then x squared y squared 3 times 4 minus, and then 48 for squared would be 16 times 3 is 48 xy, and then minus 4 cubed would be minus 64. That would be what this expression up here would become, and by using a pattern here. It's very important to use these patterns for doing these cubes. Okay, some binomial products occur so frequently that it is worth memorizing their patterns. Verify these products by using patterns like we did in the last guided practice. So this table here is valuable. Special product patterns, sum and difference, example. So we have a difference of a square here. This is our pattern, x plus 4x minus 4, x squared minus 16. And then we have a square of a binomial. So a square of a binomial would be a plus b squared. This is our pattern here. And then here's an example of it. So we just plug in our values of a and b here and plug it into this pattern. And then this is what it should yield here. Then a minus b squared, that is a square of a binomial, but it's a difference now instead of a sum. And then this is your pattern here. Then here is a numbered example of that by using a difference of a square. And then a cube of a binomial, this is what we did before, was a cube of a binomial, and that's what we did in our previous guided practice, was this situation here. And then here's an example of that here. And then we'll have a cube of a difference. We'll have a difference, and then we'll cube a difference. And then this is the situation here. We have a difference, a subtraction sign here, and a subtraction sign here. And then here's a numbered example of that. So it's very important. That page of the lesson is really important. So let's use special patterns here. So we have 3t plus 4, 3t minus 4. We have a sum and a difference. So by using our pattern, we have 9t squared minus 16. We just square our first a, and then take the negative of b and then square. Then we have a situation here where we have 8x minus 3, and then we are squaring that. So we can use our patterns here. Square of a binomial, we'll go back to our table and then plug in our values into that pattern. 8x squared minus 2 times 8x times 3. So we have 2 times ab, and then plus b squared. So we just plug in our members here into our pattern using our special product patterns, and then we come up with that for this here. Then we have a p cubed plus 5 cubed. We have a cube now. Then we have a cube of a binomial, and we go back to that table and we find our pattern that follows this, and then we plug in our members into that pattern, and then we come up with this situation here. So it's very important to have those, and if you're taking the SAT, to actually memorize those for the SAT. Okay, find the product here. We're going to do this in guided. Students, this is your independent practice here. You've got, looks like you got 2 trinomials here. So pay attention. Let's do the guided practice here. We have a binomial and a trinomial here. So how would we do that? We're going to multiply by a distributive property of multiplication. We're going to multiply this times each member of this trinomial is what we're doing there. And then we go ahead and we multiply through. And we come up with this thing here, and then we combine like terms, and then we have our final expression here after simplifying and combining like terms. Example 6, we have a word problem here. We have a crude oil situation here where the average daily oil output per well in barrels can be modeled by this, by O. W is in thousands, since the number W in thousands of United States wells producing crude oil is modeled by this. So we have wells, and then we have oil production from wells, where T is the number of years since 1980. Write a model for the average total amount of T of crude oil produced per day. So what was the average total amount of crude produced in 2000? So from 1980, to find a model for T, multiply the 2 given models. So we want the total amount of crude. So to do that, we got to multiply wells times output here. And this is our wells here, and then this is our output for each one. So to do that, we have to multiply these together, and we have negative 8.85 squared plus T squared plus this number, 8439. So we're multiplying this times that. We start here by multiplying out by 15.4, then we multiply our 0.2 times this, going in this direction here. Now we're going to combine like terms here, and we'll come up with this number here. This the 3rd degree polynomial for this This is on your class worksheet, so pay attention. So the total daily output can be modeled by this third degree polynomial here, where T is measured in thousands of barrels. By substituting T for 20, this is the year since 1980, which is year 2000, you can estimate the average total amount of crude oil produced per day in 2000. So by plugging in 20 here for T, we get about 70,000 barrels of oil a day, or 5,570,000 barrels a day of crude oil production. So now the models below give the average depth of new wells drilled and average cost per foot of drilling a new well. In both models, T represents the number of years since 1980. Write a model for the average total cost T of drilling a new well. So we have depth here, average depth here for the year. So the more newer the well, the deeper they have to drill. And then the cost here is, this is our cost function here, costs in dollars per foot for drilling a new well. And then students, this is your situation down here for your independent practice. I'm going to let you handle that. Let's do our guided practice up here. So here's our situation here. To find a model for T, multiplying the two given models together. So this is the depth times the cost per depth. And then we get this situation, 15 times 4, and we multiply out here. This is your first line here. And then our second line is created by multiplying by this. And then that would be this line of figures here. Then we combine like terms here. And then that is T is going to equal cost times D here, which is depth, cost in dollars for depth. The total cost of drilling a new well equals that. So we have 0.542 minus 7.16 T plus 79.4, which is our cost function here, and then times 109 T plus 4,010. We're going to multiply that together, so our total cost would be this number here. So write a model for the average total cost T of drilling a new well. And so that would be lesson 2.3, part 2. And part 3 will be available here. Worksheets, tests, quizzes, tutoring, etc. available here as well. Thank you very much.